So we're given the following function, fxy equals e to the power minus the square root of x squared minus y squared. And what we have to do, we have to determine the domain and the range. So this is assignment 2, question 1. Alright, so first for the domain. So we need to figure out which part of the function is it possibly not defined for, and the only thing that we have here is a square root. So the thing below the square root must be non-negative. So the only requirement that we have for the domain is that x squared minus y squared is non-negative. So in the formula we could write the domain like this. These are all vectors x, y in R2, such that, let's say, x squared is bigger or equal than y squared, or x squared minus y squared is non-negative. That is the same. Now the question is to sketch this. So the easiest way is just to start with this equation. I will present two ways of doing it. And then just expand the left hand side, because we can write this as x plus y times x minus y is non-negative. And now, okay, so now if the product of two numbers is non-negative, product of this and that means that either both of the numbers are positive, or either both of them are non-negative, or both of them are non-positive. That's the only way that the product of the two of them can be non-negative. So this has two solutions, namely that x plus y is non-negative and x minus y is non-negative. Or both of them are non-positive. So x plus y is non-positive and so is x minus y. So we have two different solutions. So let's start working out the first one. So the easiest way is to rephrase everything in terms of y. So if we rephrase the first equation, we get that y is bigger or equal than minus x. And for the second one, we get that y is less or equal than x. Right? If we make a little picture. So how do we put this, these two conditions here? Let me circle them in red. How do we put them in the picture on the bottom left? Well, we just draw the graphs of the two equations that are involved here. So y is less or equal than x. We just draw the graph of y equals x, which is this one. And we draw the graph of, this goes through the origin, and the graph of y equals minus x, which is this one. So this is y equals minus x. And then we're looking for those y's which are less than x but bigger than minus x. So less than x must be below this one, and bigger than minus x is above this one. So we see it's everything in between these two graphs like this. So these are all the solutions of the first equation. Now also we have the second equation, so we're going to rewrite that in the same way. Again as y, so the first one is y is less or equal than minus x. And the second one is y is bigger or equal than x. So again, let's do them in blue. These two equations, we again go to our picture. We already have the y is x and the y is minus x. So y is bigger or equal than x, which means, let's do this one in blue. So I'm bigger than this one, and I'm less or equal than minus x, so I'm less than that one, right? The line is where y equals minus x, so y is less or equal than minus x is below that. And then we see that the blue part can be shaded like this. And so together, let's make everything black. Together we get these two regions. we have to think about the boundary. Well, we have less or equal everywhere, so we always include the boundary, which was, if you remember the worksheet, in the worksheet we omitted the boundary, but in this case we include the boundary. That is why we draw a thick line and not a dotted line. Okay, so the second way of, so I think this is the easiest way. The second way of solving the equation is to look at the equation where x squared is bigger or equal than y squared. And then, okay, so these are two positive numbers, so I can take square roots on both sides, which is a monotone function. So from this, it implies that if I take square roots, I will get the absolute value of x is bigger or equal than the absolute value of y. Remember, because the square root of x squared is the absolute value of x, and the same for y. So the top equation implies the bottom equation by taking square roots and using the fact that the square root is a monotone function. If t is bigger than s, then the square root of t will also be bigger than the square root of s. But also the bottom function implies the top function because we can apply the square function. If I square both sides, we get the top equation. And also the square is a monotone function. If t is bigger than s, then t squared will be bigger than s squared. So each equation implies the other, therefore the two equations are equivalent. So if I want to solve the top equation, I may as well solve the bottom equation. So this is an important step. Whenever you do these operations on equations, you must make sure that the solutions are exactly the same. In other words, that the equations are equivalent. So to solve the bottom equation, I think it's easiest just to split it up into 4 cases, because the absolute value has 4 different behaviors. So for instance, in the first quadrant, we have that x is non-negative and x is non-negative and y is non-negative, and then the equation just becomes x is bigger or equal than y. And what is that? Well, this is the equation where y equals x. So if x is now bigger or equal than y, let's see, y is less or equal than x. Let me write it like this, sorry. Just the same way we did it the other way. So we have that x is bigger or equal than y, but we can rewrite it like this, that y is less or equal than x. This line is the equation where y equals x, and therefore if y is less or equal than x, we have this region over here. Yeah, it goes on forever, but I don't have enough space. And this is only for the region where x is non-negative and y is non-negative. So for instance, for the second one, where x is non-negative but y is non-positive, what equation do we have? Then we have the equation where now the absolute value of y is minus y, so we've got that minus y is less or equal than x. In other words, y is bigger or equal than minus x, and therefore we get this region. And this way you will have to do all 4 of the quadrants, and then once you do this, you see you get the same solution as we got over there. So that's, I think, slightly difficult because you have to consider 4 different cases. Okay, so that is the domain. Here's the formula. Let's do it in red. So the formula is over here, and the picture is over there. So these are the 2 answers to the first part of the question. And now I will continue with the range of this function, for which I will clear the slide. So let's rewrite the function. So for the range, the first thing that we should think about is, well, it looks like an exponential function. So we should first figure out what are the possible values that can be taken by, say, the exponent here, which is minus the square root of x squared minus y squared. So let's call this exponent t for the moment. So we're considering the function e to the t. Well, we can quickly sketch e to the t. That looks like this. So what values does t take? Well, t is the negative of a square root, so it only takes negative values. In a moment I'm going to argue that it will take all the negative values, so all the possible values for t are over here from 0 to minus infinity. These are all possible values for t. I will argue that in a second. And then we see that the values that the function takes, which is, let's say, the blue part of the graph. So these are these values. These are all the values from 1 and less than 1. So that's actually, let me write it down, the range of the function f. I already claimed that it does not include 0 because the exponential function will never take the value 0, but it goes up to 1 because if t is 0 then it goes up to 1. So now it remains to prove, well, you don't actually have to prove this, you just have to give the range. So we should argue that t can take all possible values. And how the easiest way to see this is just consider the function where y equals 0. So then we get e to the minus square root of x squared, which is e to the minus the absolute value of x. And now t is equal to minus the absolute value of x. And as you can see from your picture of the domain, x can be anything if y equals 0. So this can take any negative value. So indeed we can plug in any negative value in the exponential function, and therefore the range is exactly equal to this. So this is sort of the intuition that you should have in a question like this, in order to determine the range. Okay. Now let us continue with question 2. We have to sketch a certain function. So the function that we are working with is, so I will take alpha as 5 again in my explanation. It might be slightly different, but it will be the same. In this case it's fxy is the absolute value of y plus 6. And the question is to sketch the graph of the function. Now, as you know, to sketch the graph of a function, we should first compute the intersection with each coordinate axis. So let's start with the intersection of the graph with the plane, with the xy plane, which is the plane where z equals 0. So I'll write it down like this, just to write all the steps. So these are the points x, y, z, such that first it must be on the graph, and the equation of the graph is that z is equal to fxy. And fxy is the absolute value of y plus 6. Furthermore, z must be equal to 0. And then in the second step, we just plug in z equals 0. So this is xy 0, such that 0 is equal to the absolute value of y plus 6. So we're looking for all x's and y's such that 0 is equal to the absolute value of y plus 6. Well, the absolute value of y is of course always non-negative, and if I add that to 6, I will get something that's non-negative. So this equation over here, the red equation, is never satisfied for no values of x and y. Right? So in one symbol we could write it like this. So this is the symbol for the empty set. There are no x and y's that satisfy the equation, therefore this set is the empty set. So there's nothing to sketch. So that was the intersection with the xy plane. Now let's compute the intersection with the xz plane. Let's do it the same way. If you want, you can do it a little bit shorter, but I will just be very precise. So z is equal to fxy. And now y equals 0. Therefore, plugging in y equals 0 will give me x, 0, z, such that z is equal to 6. Okay, so now let's draw this in the xz plane. Let's do it over here. X, z, z equals 6. So this is what it looks in the xz plane. Finally, let's look at the intersection with the yz plane. Those x, y, z's, such that again z is equal to fxy and x equals 0, which will give me that 0, x equals 0, so we get 0 yz, such that, well, there's no x in this equation, so this equation just remains the same. Okay, so let's write this in the yz plane, so yz. Okay, so now we have to find the graph of this equation. Well, if the 6 was not there, it was the absolute value of y. We all know from the first year what it looks like. Now we just add an extra 6, so we just lift up our, let's write it in dotted lines. We don't have this. This would just be the absolute value of y. We would have the same thing plus 6, so we just add 6. So that is what it looks like. Alright, I think I will just continue to the next slide and plug these two things into a 3D picture. Because after we do all the intersections with the coordinate planes, we usually put it into a 3D picture and see what we have so far. So let's do that. Yeah, let's do it over here. So this is the x-axis, the z-axis, and the y-axis. So we had in the xz plane, that's the plane over here. Okay, I cannot really show it, but we had that we are equal to 6. So let's say 6 is over here. Unfortunately, I cannot draw. Let's say 6 is over here, and we have a line that goes through 6. Yeah, that's the intersection with the xz plane. Then for the xy plane we had nothing, we had an empty set, so we don't write anything. And then for the yz plane we had this picture which I showed before, which looks like this. Yeah. Okay, so I'm not quite sure how this picture looks like, so I think I need more information. The first thing that makes sense to do is, well, we had no intersection with the xy plane, so let's look at the level set. So let's look at the graph of f intersected where the plane, where not z equals 0, but z equals k. This makes sense because when we did z equals 0, we had nothing. So it makes sense to now set z equal to k. Note that in some other questions it may also be possible to set y or x equal to k. But in this case, I think it makes more sense to set z equal to k because we had no solution for z equals to 0. So what do we get? We get those x, y, z's, such that, again, z is equal to fxy, and now z is not 0, but z is k. So let's plug in z is k, so we get x, y, k, so that k is equal to the absolute value of y plus 6. So when we do these level sets, we usually take k in the range of the function, and we can see here that k must be bigger or equal than 6. So how can we conveniently rewrite this equation? Just to make it more clear. So this is an equation where y is the variable. So this is in the xy plane. Well, there's no x left, but so we should rewrite this equation such that we isolate y. And that means that y is equal to k minus 6. Which will have solutions as long as k is bigger or equal than 6. Yeah, so let's draw this in a two-dimensional picture. Remember we have an x and a y, we don't have a z, so we have x and y here. And then the absolute value, now we need that the absolute value of y is a certain value. So, okay, let's continue in red. When is this absolute value of y this value? So here we should assume that k is bigger or equal than 6, otherwise there will be no solutions, by the same reason that we had no solution for k equals 0. So the absolute value of y is some positive number. This will happen when y equals k minus 6, or y is equal to minus this number, which is equal to 6 minus k. Yeah? These are the two solutions of the first equation. So we basically get two solutions. So we have k minus 6 over here, and we have 6 minus k over there. So this is the point 6 minus k, and this is the point k minus 6. And again, k minus 6 is positive, and 6 minus k is negative, because k is bigger or equal than 6. So yeah, so k minus 6. So let's put this picture also in our 3D picture. So we have k minus, oh, we have k minus 6, which is bigger than 6 because k is bigger than 6. And then we've got those two lines in the xy plane, so that they will go like this. But now we're a little bit higher, so we are like this. We have two parallel lines going in this direction. So now we get a slightly better view on how it looks like. Now I want to conclude the following. Okay, so there are now two ways to proceed basically. So the first way, I will do the way that I would do it, is I would say that let's write the function again. f(x,y) is equal to y plus 6. So this function does not depend on x. Right? Because it doesn't matter what x is, I will always get the same thing. So if x is 0, I get I get this kind of picture over here. We've already done this. But if say x is a different value over here, say 2 or 3, whatever, we should get the same picture like this. And if x is some negative value, we also get a picture like this. Okay, these things are supposed to lie parallel. But if you argue like this, then we see that the thing is really, how can you say that? It's like a roof but inverted. So it's like a gully where water flows through. So that is the total picture. Another way to do this is just to compute. Yeah, so this is one way. You should argue like this and write it out. So that doesn't depend on x. So the picture is okay. Now I'm saying the 2 times is in the. Okay, let's not say this. So how should we say this? This function does not depend on x. So the picture in the yz plane repeats. Or some similar argument, as long as you make it clear that you understand that it doesn't depend on x, so that the picture repeats. So that's one possible way of doing it. Another way, let's do that in orange, is you could also say just compute the graph of f intersected with the plane where x equals k. And then once you do that, well, you realize you get exactly the same formula as before, because the x does not appear in there, and then you write them in your picture, and then you see the same thing. But both options are completely valid, and this is roughly the final picture that you should get. And that finishes the explanation.